Open your book to page 188. So this lesson is using the using the factoring to solve the word problems. So you need to know how to read and translate, and then you have to factor and you have to solve. So let's go to example 1. So when you're doing a word problem, first you need to do is read to get an understanding of the problem. It says the end of the large tent is in the form of an isosceles triangle. Okay, so right away you draw a triangle. Isosceles means two legs are congruent, right? And whose area is 18 meters square. So area equal to 18 meters square. So you want to draw your picture and write down all your information. And it says whose base is 1 meter less than twice of its height. Okay, so what you want to do is, okay, so it is a height, right? So base is, right, again, that's how you translate. You write things down as you go, right? So base, so that's B, is means equal, 1 meter, so that's 1, is less than, so you have to put in the back, right? So 1 less than twice its height. So again, base is 1 less than twice its height. Okay? And you use the second variable as your reference. So that is your picture. Okay? So now you need to go and find a way to solve this problem. So the area of the triangle, again you substitute, the area of the triangle is 1/2 base times height. Okay? So again substitute area into 1/2 base times height because that's the formula. Then after that you substitute. Whenever you see equal, there's your clue. You need to substitute that. So it'd be 1/2. Okay, base is 2h minus 1 times h equal to 18. Okay, so that's your equation. So next, what you do is to solve this, right? If you multiply this right now, it gets messy because it gets half. So what you want to do is you want to multiply both sides by 2 to get rid of the half. So multiply by 2, multiply by 2. So this cancels out. So this becomes 2h squared minus h equal to 36. And so now you're in familiar territory now. You're going to make it equal to 0, so you can do factoring, you can solve. So minus 36, minus 36. So you got 2h squared minus h minus 36 equal to 0. And then you can do the factoring. Okay, common factor cannot, spatial factor cannot, cube cannot. So master product, -1 and -72. Okay, so you can make sure you remember to multiply. So this is going to give you a comma -9. So you start with h and 2h. So this will be the inside, right? So 2 times 4, right? 2 times 4 give you 8, and this will be the outside. So 1 minus 9. Okay. So from here you're going to get h equal to -4. This one is not as obvious, so you can set it equal to 0 and solve. So 2h equal to 9 divided by 2 divided by 2. So h equal to, now you can use decimal, you can use fraction, it doesn't matter. And you have to put in the label, right? So height is 4.5 meters. Now it says find its dimension. Find dimension means you're looking for the base and you're looking for the height. So once you find the height, you can come over here to find the base. So base equal to 2 times h minus 1. So base equal to 9 minus 1. So base equal to 8 meters, and that's it. Okay. So again, so that's how you do the word problem. By just read, draw your picture, label whatever, and work it through. Okay. Now let's go to example 2. Example 2, it says when a projectile is launched from a ground level, it achieves its maximum height at a time halfway between the launch and its impact time. If the object is given an initial velocity of 49 meters per second, t represents time in seconds, and h represents the height in meters. Then h equal to 49t minus 4.9t squared. It represents the object's height above the ground and at a time t. And so you're looking for maximum height for this launch. So basically what you do is they give you the equation h equal to 49t minus 4.9t squared. Okay. And so h is the height of the object, of the projectile. And t is the time associated with the height. Okay, so again, h is the height. And so you're looking for the maximum height. Okay, so basically what happens, you have a projectile like this, and it shoots up and it then back on the ground. Okay, and it reaches maximum height at halfway between. So you're looking for that. So first thing you need to do is you need to find out the time it takes. So what you need to do is first you need to find the time that it took from here to here. Once you find how much time it will take to get here, then you can divide by 2 to find the time over here. And once you find the time over here, you can find the height over there. Okay? So that's what you need to do. So over here, the height equal to 0, and when it hits the ground, height equal to 0 again. Okay? So to find the time, you can set h equal to 0 to find out the time over here. So you can here your time equal to 0, here time equal to you don't know. Okay? So that's what you want to do. You substitute h equal to 0 because when it hit the ground, the height is 0, right? So that h equal to 0. Okay? So you're looking for time over here. And then after that, you can, so because it's the equation, you can get rid of the decimal, right? You can divide by, let's go divide by negative 4.9. So divide by negative 4.9, divide by negative 4.9, divide by negative 4.9. Okay? Again, I'm doing that to get rid of the decimal. So you're going to get 0 equal to, and so this will give me 10t squared, and this will give me, no, not 10t squared, just t squared. So this will give me t squared, and this will give me negative 10t. Okay, I'm going to rearrange the order so it looks nicer. So you get t squared minus 10t. Okay. And after that, I'm going to find out the t. So I got t minus 10. And so I got t equal to 0, t equal to 10. So t equal to 0 is when it's over here, right? When h equal to 0. So again, you got two answers. So again, so t equal to 0 is when it's over here, and t equal to 10 is right over here. Okay? So it takes 10 seconds to go up and come back down over here. Okay, so t equal to 0 here, t equal to 10 over here. That means at the maximum height, t will equal to 5. Right? Does it make sense? Right? Halfway between, right? So if you're looking for the height over here, so you can figure out your maximum height now. So you will get maximum height when t equal to 5. So use the equation again. So you got 49 times 5 minus 4.9 times 5 squared. Okay, you work it out. So h equal to 122.5. And the label would be, that's how that means, meters. There you go. Okay, and that's it. So you have to use the equation over and over. Okay, now let's go and do one more example. Let's go to page 191, and let's do number 24. So that's the instruction right above it. Okay? It says in problems 23 to 26, you were using the formula. So you have this formula, h equal to k plus vt minus 4.9 t squared. And the picture tells you what k is. K is the starting height. Okay? So if you start from the ground, then k will equal to 0. Right? And h is the height of the object, and t is the time, and v is the initial velocity. So for number 24, it says a ball is throwing upward at the top of the tower. So you have a top of, so here's a tower, and so over here k is 49. Right? Again, top of the tower, and it's throwing upward, and it's going to come back down. Okay, so that's the picture you have. And again, the tower is 49, so that's k equal to 49. And with initial velocity of the speed, so that's the speed equal to 14.7. It says up to how many seconds will it strike the ground? So you're looking for t equal to question mark when it hit the ground. So that means the height equal to 0. Okay, so you need to understand all that. Okay, so all you have to do is just plug everything in here. So you want to find out the time when when it hit the ground. So that means height equal to 0, right? When it hit the ground, the height is 0. And k is the height that you start. So k is 49. And v is the initial velocity or initial speed. So it's 14.7 t minus 4.9 t squared. Okay? So again, you're looking for the time that it will hit the ground. Okay, so that's the equation you have. So what I'm going to do is I'm going to move everything to this side. Okay? Because I don't like the negative in front and I don't like it on that side. So I move everything to this side. So I end up with 4.9 t squared minus 14.7 t minus 49 equal to 0. Right? Again, when I move this over, the sign becomes opposite. Right? Then what I'm going to do next is that since this is the equation, I can divide by, or I can multiply the number to get rid of the decimal. So I'm going to divide by 4.9, divide by 4.9, divide by 4.9. So I get t squared minus 3t minus 10 equal to 0. And do the factoring, so negative 3 and negative 10. So I get 2 comma negative 5. Okay, so I get plus 2 minus 5. So t equal to negative 2 or t equal to 5. And obviously this is the one we want. Okay. Now the significance of t minus 2 is, imagine that instead of, let's say instead of throwing the ball from the tower, okay. So this is when t equal to 0, right? So imagine that if you shoot it from the ground instead. So this is t equal to negative 2. So that's why it's negative 2. Imagine that instead of starting up here, if you go backward, you would go backward 2 seconds. So imagine that instead of throwing the ball from the tower, if you shoot it from the ground, okay, that means 2 seconds backward. Okay, that's what that is. Okay, so let's go and do some practice.